Hi, today we are doing lesson 4, and again it is equivalent ratios. We're going to start with a classwork and example 1. So I'll read it and you can follow along. The morning announcement said that 2 out of every 7 6th grade students in the school have an overdue library book. Jasmine said, "That would mean 24 of us have overdue books." Grace argued, "No way, that is way too high." How can you determine who is right? Well, the first thing we probably should do is think about what the problem is about. So take a minute. What exactly is happening here in this problem? Okay, now what do we need to find out? What's the problem asking us to find? Well, how can you determine who is right? Is what the problem is asking us to find. We need to figure out if Jasmine is right or if Grace is right. Okay, so now we've got that. What information do we need to pull out of here? Well, since we're talking about ratios, we probably need to find the ratio. The morning announcement said that 2 out of every 7, there it is, 2 out of every 7. That is our ratio, and let's change that color. Where is our color? There it is. 2 out of every 7 is clearly written as a ratio. And let's change it to a cool color like pink, because it stands out. So 2 out of every 7 is our ratio. 6th grade students just tells you what type of students they are. So out of every 7 students, that means, let's see, our ratio could be 2 to 7. That makes sense. Okay, so since we're trying to find equivalent ratios, we need to find a ratio that is equal to that and see if we have it in here. Jasmine said that would mean 24 of us have overdue books. Well, I think the 24 here fits as part of our equivalent, possibly equivalent ratio, because Grace said that was not correct. If this does end up being correct, then we would have another number here that would fit, and this would be equal to these numbers. Now, question is, are these equal, and is that one, do we know what that number is? Let's see if we can't figure that out. So, if you remember from our last lesson, we were told some information. And our information was, how do we figure out if 2 ratios are equivalent or not? So, what we were told were some letters, which seems probably complicated. So let's look at the letters a little bit clearer now. If we have 2 letters, A and B, which represent any 2 numbers. So in this case, it's 2 to 7. We have 2 letters, A to B, and we multiply them. This sign here means multiply. We multiply them by a number that is the same number, and we notice at this point it's represented by the letter lowercase c and the letter lowercase c over here. That means it's the same number. So if we have 2 numbers in a ratio, we multiply both of them by the same number, then the next 2 numbers we'll get, that would be the C on the side, the new capital C, would be the same. So for example, A times C will equal this C. B times a lowercase c will equal this capital D. And if that is true, then it is an equivalent fraction. So let's see if we can come up with what we mean here. Okay. If we have a number, let's get a good number here. The number 4 to 5, so 4 to 5, and we multiplied 4 by 2. We have to multiply 5 by 2 as well, because the lowercase c had to be the same, so it has to be by the same number. So if we did that, then 2 times 4 would equal 8, and 2 times 5 would equal 10. And that's how we know that we have an equivalent ratio, because 2 times 4 is equal to 8, and 2 times 5 is equal to 10. And that's based on the information we have here, that we have equal ratios. Okay, so now we have the information on what we have to do. Let's go ahead and erase this. We don't need it anymore. And let's see. 2 times something will give me 24. So let me think about this for a minute. 2 times what will give me 24? I'm going to say 2 times 12 will give me 24. And 12 times 2 I know is 24, so that makes sense. I could also have done it backwards and said 24 divided by 2, and that will give me the 12. Now, based on our rules, if this one is 12, then we have to multiply the 7 by 12 as well. And 7 times 12, if you take a minute, go ahead and figure that out on your paper, is 84. So our equivalent fraction, 2 to 7, maybe write it over here, 2 to 7 would be equivalent if the numbers are 24 to 84. And as long as we know how many students there are altogether in the 6th grade, then we could say that Jasmine is correct. But we would need to know if 84 is in fact the next number of students. Without knowing this information, we really can't determine who is right. So if we were going to create an equivalent ratio, it would be 2 to 7 is equal to 24 to 84. So Jasmine and Grace depends on how many students there are in the 6th grade. Okay, with this information, let's move on now to exercise 1. In exercise 1, our job is to determine whether or not each of the following pairs of ratios is equivalent. If the ratios are not equivalent, we're supposed to find a ratio that is equivalent to the first ratio. Okay, if the ratios are equivalent, we have to identify the non-zero number, C. That would mean this number that's here that goes in parentheses. That could be used to multiply each number of the first ratio in order to get the numbers for the second ratio. Okay, so if we have it correct, we have to say what number has been multiplied by both to get these numbers. If, however, it's not an equivalent ratio, what number could we multiply it by to get equivalent ratios? Make sense? I hope so. Let's give it a whirl. Okay, so here we go. We're going to start with 6 times something will give me 42. So 6 times what gives me 42? You know your multiplication tables. It's 7. Okay, so 11 times 7, because it needs to also be 7, should equal 88. But 11 times 7 does not equal 88, does it? No, it equals 77. That being the case, is this an equivalent ratio? No, it's not. So over here, we write a capital X on the no. No, it's not. Not the X because it's no. No, because the X because it marks it here. So an equivalent ratio, however, could be, and what did we just see when we drew it in? You have it on your paper. I had to erase it. 6 to, that's not a 6. 6, there it again, 6 to 11 is equal to 42 to, do you remember? 77. So that's how we do it. This one is not an equivalent ratio. However, it could be an equivalent ratio if the 88 was instead 77. Okay, let's look at the next one. 0 to 5 and 0 to 20. Okay, so what do we multiply? This is not that hard. What do you multiply 0 by to get 0? Multiply it by 0. But anything multiplied by 0 is 0. Let's try this. What do you multiply 5 by to get 20? Right, you multiply 5 by 4. And then we get 20. What happens if you multiply 0 by 4? What is 0 times 4? It's 0. So if we're not careful, if we go only by the first number, we could be incorrect because this does work as a ratio. This the number we're multiplying it by cannot be 0. That's important to note. But we can multiply 0 by 4 and still get 0. And we can multiply 5 by 4 and get 20. So yeah, this can be an equivalent ratio. And what number do we multiply both sides by? We multiply both sides by 4. All right, so that was the trick. Now we're going to look at exercise 2. In a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. Determine the number of walnuts that are in the bag if there are 54 cashews. Use a tape diagram to support your work. Justify your answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. So before I show you the answer, I'm going to ask you to go back in your work to a couple of lessons to remind yourself how to do a tape diagram, and then go ahead and try to do this one on your own. And then we'll come back and I'll show you the answer. Okay, so if you set it up with your ratio 5 to 6, because 5 is walnuts and cashews are 6, and we know that there are 54 cashews, so we put cashews where the cashew side is, we need to know how many walnuts there are. Well, our tape diagram should look something like this. The original ratio, 1, 2, 3, 4, 5 to 6. 1, 2, 3, 4, 5, 6. This one is walnuts, this one is cashews, and we know that there are 54 cashews. Now all we need to know is what number goes inside each one of these units. Well, you can figure that out by saying 54 divided by 1, 2, 3, 4, 5, 6. That will give us 9. And we know that if we have 9 here in these boxes, that there are 9 in these boxes as well. Which tells us then, we have 9 units here times the 5 of them that there are 45 walnuts. Okay, so let's go back and see if we've figured everything out. We were to determine the number of walnuts that are in the bag if there are 54 cashews. So let's underline that. Okay, we were to use a tape diagram to support our work, and we did. Now we had to justify our answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. Okay, so let's come down one more and say 5, oh, I can't do those right, 5 to 6 is equivalent to 45 to 54. And let's use our new way of figuring it out. So we can say that 5 times 9 equals 45, and 6 times 9 equals 54. And that's how we prove that 5 to 6 is equivalent to 45, is equivalent to the ratio of 45 to 54. Not bad. All right, let's do our lesson summary. Recall the description. Two ratios, A to B and C to D, are equivalent ratios if there is a non-zero number, lowercase c, such that C and A, lowercase c times the A, and then the D and the lowercase b times, and the b times the lowercase c are equal. If c is equal to the lowercase c and the a, and d is equal to the lowercase c and the b. For example, two ratios are equivalent if they both have values that are equal, which basically was what we showed you earlier today. Ratios are equivalent if there is a non-zero number that can be multiplied by quantities in one ratio to equal the corresponding quantities in the second ratio. So what we want to keep in mind when we're looking at this, and we talked about before the lowercase c, this lowercase c has to be a non-zero number, because if you think about it, if this was a 0 and that were a 0, it couldn't possibly be equivalent because everything would just be 0. So that's why the lowercase c has to be a non-zero number. The other thing we want to remember is that when we're looking at these boxes, inside the boxes, that's where our c is. So we multiplied the 5 times 9 and got 45, and the 6 times the 9 and got 44, so that there were 9 inside. When we talk about what number is inside here, it is the lowercase c that we're talking about, which is the number that can be multiplied by both. Okay? All right. Exit ticket. Learning this today was probably not as challenging, but hopefully more clarifying for you. But this might be challenging. Let's see. There are 35 boys in the 6th grade. The number of girls in the 6th grade is 42. Lonnie says that means the ratio of the number of boys in the 6th grade to the number of girls in the 6th grade is 5 to 7. Is Lonnie correct? Show why or why not. Kind of like our first question, only we do have the numbers for both ratios. So give it a try. See if you can figure it out and see if you get it right. Remember, the problem set that we encounter later is your homework, and there are only 3 questions this time.